Okay, in our last lesson for Math 111, we introduced you guys to function notation. All of your graphing with two variables has done to this point with y equals something. So let's look at some examples. We would have like y equals x minus 4. And then we would say if we wanted to designate which numbers to use for x, we would simply say let x equals 0 and x equal a negative 1 and x equal a 2. And what you would have to do once you have designated these by let x equal, then you would put the number in for the x, 0 minus 4, which gives you y equals a negative 4. And then you could put in the negative 1. Y equals negative 1 minus 4, which gives you y equals negative 5. And then you would put the 2 in and have y equals 2 minus 4, which gives you y equals a negative 2. So you get your values by substituting the number in for x, and it's all this designated by let x equal this, let x equal this, let x equals this. And it's not always the easiest way to deal with functions. So another way, and these make ordered pairs. So this would be 0, 4, this one would be negative 1, negative 5, and this one would be 2, negative 2. So it builds your ordered pairs. Now, the other thing that we're looking at is the function idea. Now the function idea is kind of like saying, I have a toaster. When you have a toaster, if you put one slice of bread in the toaster, what comes out of the toaster? One slice of toast. If I put 2 slices of bread in the toaster, 2 slices of toast come out. So you see you're doing opposites like that, what goes in and what comes out. And so we might say the toaster at 1, in other words, 1 slice of bread gives you 1 slice of toast. And so our function notation replaces the y with the symbol f at x. And this x can be any number you decide it can be. In this case, my f of x equals x minus 4. You see the equation didn't change. The only thing that changed was the function, was the notation. And this means a function of this. And what this is it does the same thing to everything you put in it. It's kind of like the lathe machine. It's a machine that makes fancy chair legs and fancy table legs and other fancy things. You put the wood on it and you set the program of the machine, and the program proceeds to do all the work and produce the fancy chair legs that are always the same. So that's kind of the way I think of function notation too. So then we're going to say, what is my function at x when x is 0? So f, my function at 0 is going to equal 0 minus 4, which is a negative 4. So my function at 0 equals negative 4. See, on here we had to designate it by ordered pairs. Over here I don't, because my x is here and my y is here, because 0 minus 4 is a negative 4. And then my function at negative 1, again, negative 1 minus 4 is a negative 5, so my function at negative 1 is negative 5. And my function at 2 minus 4 is a negative 2, so my function at negative 2 equals 2. And you notice I didn't have to write them in ordered pairs. I could, but I didn't have to. Okay. We also use these same things in charts. We can do our x, y chart, and that's a real handy chart that we use a lot for graphing. But we can also change it to my x and my f of x. And my f of x is the result, just like the y is. So we can use those different charts to help ourselves out. So one of the things they're doing in problem number 7 and 8, they give you a chart such as -4, 0, -2, 7, 0, 14, 2, 21, and 4, 28. And then they'll ask you the question, what is f at 4? So what is f at 4, at negative 4? So what is f at negative 4? Well, f at negative 4 is going to be this number, so you find the negative 4 in the x, and then look at the f of x column, and that gives you your answer. So f at negative 4 is 0. How about f at 2? Again, you're going to go down the x column to find the 2, and look at the f of x column right beside it, which is 21. And then we have f, but what if they say f at x equals 14? So f of x equals 14, so what is my x? My x is 0. So in this case, x equals 0. So you can go either direction. If they give you the f of x equals a number, you look in the f and x column until you find that number. Then you go back and find what the x was that gave that number. And they do several of these problems. And so let's look at this one. This one is very different from anything you've done so far. We've got a negative 4 and a 4, a negative 2 and a 2, 0 and 0, 2 and 2, and 4 and 4. Okay, so f at negative 2. Well, what is f at negative 2? It is 2, right? And now f at 4. Well, f at 4, here's my 4. Here's my f at 4, so it yields me a 4. Now what if it says f of x equals 4? Well, that means I'm going to look in my f of x column. I have 1 4 here and 1 4 here. Therefore, what's going on here? Well, I have two x values that produce a 4, so therefore my x is equal to a negative 4 and a 4. So there's two potential values that produce that number 4, and you have to list both of the x values in this case. So that one's a little bit different than the others you have done. So then let's look at a graph and work it that way by looking at a graph. Okay, so let's look at this graph. Okay, there's my x and my y axes, and now let's look at this line. Okay, as we look at this graph, we see from here to this direction, this line is 3 above the x-axis, and it's going to go on infinitely in this direction. From here to here, we have a slope to it, and it's kind of a 45-degree line. And then from here, we're going infinitely in this direction, and it's all at this same number, okay? So now, what if I ask you, what is f at 0? Well, that's easy to find. F at 0 is 0. So from the graph, we can get that. Then what about f at -1? Well, let's go to -1 on the x-axis, go up, and where is it on the y? Well, it is also 1. My drawing's not the best. Okay? And how about f at 1? Well, f at 1 is here. I come down, and that dot is at -1. And then what if I ask you f at x equals -3? Well, what happens? From here on into forever, this graph is all going to be at -3. Therefore, my x is going to be greater than or equal to the number 3, because this is the 3 on the x-axis. So from 3 on, it's always going to be a -3. So x is greater than or equal to a -3. So that takes care of that one. And that's kind of interesting. What if I ask, what is f at -10? Well, I haven't actually drawn the graph with a -10. But what's true about this line up here? It is going infinitely on forever at that same value, and that value is 3. So therefore, f at -10, which might be about out here, is still 3 because that line goes on. So this is going to be a positive 3. So there it is. That gives you the various ways that we can look at this and see what's happening with it. All right.